Hi, in this video I'm going to define an absolute value function, and then we'll see some examples on absolute value function. Okay, how to find the value of the function for an absolute value function. So if a function fx defined piecewise in this way, this function is called absolute value function. So f of x is x if x is positive or 0, and f of x is negative x if x is negative. If the x is negative, you just multiply that by negative. If x is positive, then you just get that x. Okay, so this is the definition of the absolute value function. But in short, instead of writing two pieces, sometimes we write this notation as a single piece. Okay, f of x equals to these two bars around. So that's called absolute value, or sometimes it is called modulus. So absolute value of x. So this is the short form for this piecewise function. Okay, and the name of this function is absolute value of x. So now we want to draw the graph of absolute value of x. So how does it look like? Okay, so to draw the graph, first of all we need to draw the graph for x greater than 0 part, and then or draw the graph for x less than 0, and then draw the graph of the other part. Okay, for x greater than 0, for this part, okay, for this part, this is the domain starting from 0 to 1, 2, 3. This is the domain, and we want to draw the graph for that. Okay, let's take this function here. So here f of x equals to x. So we pick different values of x there. When x is 1, y is 1. When x is 2, y is 2, and then when x is 3, y is 3, and so on. So let's plug in those points. When x is 1, y is 1. When x is 2, y is 2. Somewhere here. When x is 3, y is 3, somewhere here. And then you draw the graph, okay? Oh, it should be here, somewhere here. So this is the line, this is the graph that is right to the 0. When x equals to 0 though, when x equals to 0, what do you get for y? Y will be, f of x will be 0, because when x is 0, f of x will be 0. That is basically y. This fx is basically y, right? So y is 0. So this is another point. So for the right to 0 and including 0, we draw this is a line. For left part though, for left part, when x is less than 0 means left to 0, the f of x is negative x. So this is we want to draw now. So let's plug in negative 1 for the left part. When x is negative 1, then y will be negative, and then x is negative 1, negative 1. That is basically 1. Did you see that? Similarly, when x is negative 2, then you will get negative and then negative 2 for y, because y is equals to negative x. So that is 2. Similarly, negative 3, it is 3, and so on. Okay, let's do that. Negative 1, this will be here. Negative 2, this will be here. Negative 3 will be somewhere here, right? And then you draw the line. So the graph of the absolute value function is basically the v-shaped. Did you see? And all the part of the graph is above x-axis. You can see from here that the graph is v-shaped, and then all the part of the graph is above x-axis. So the absolute value function gives always a positive value, because see, at 1 the height of the function is 1, 2, 2, but also when x is negative, you can see the height of the function is positive. So it is always above the x-axis, and it keeps going that way. You can write an arrowhead there, meaning that it is going that way. So it is a v-shaped. Okay. Now this is the value of the this is the graph of the absolute value function. Now we want to find f at 1. What do you think f at 1 would be? When x equals to 1, should you look at the first function or the second function? It is first function, right? Because 1 is great. For all x positive, you pick this function. So 1 is positive, right? So you pick that function. Now you plug in x equals to 1, you will get 1. How about f at negative 2? So for all x that is negative, you pick this function for fx, right? So for x is negative 2, you replace x by negative 2. It will be negative 2, that is positive 2. And then finally f at 0. When x equals to 0, you pick this value of the function. So replace x by 0, that will be just 0. Okay, so this is basically the definition of absolute value function, and how to draw the graph of that absolute value function, and how to find out some of the values of absolute value function. Here in this example, you see that the f of x defined this way is called absolute value function. So the shortcut notation for this one is f of x is equals to absolute value of x. Basically, this absolute value of x is like x if x is greater or equals to 0, and then negative x if x is less than 0. So this is the definition of the absolute value of x, right? So let's take the second example. In this example, you have let gx equals to 2x minus 4 with the absolute value, and then write gx in the piecewise function. So you want to write this gx as given by absolute value of 2x minus 4 equals to, so what are the two pieces? So if you follow this definition, if you have something inside the absolute value, so for x greater than 0, for this thing greater than 0, you just write that, meaning that here you have 2x minus 4 inside the absolute value. So you write 2x minus 4 if that thing is positive. 2x minus 4 is positive. Did you see that? If this quantity is positive, you write just that thing, whatever here is, if that quantity is positive. But if this quantity is negative, then you multiply this by negative to get rid of the absolute value. You multiply this by negative if that is negative, if this quantity is negative. So whatever quantity inside the absolute value, if this quantity is positive, then you write this exactly the same thing. If this quantity is negative, if 2x minus 4 is negative, then what do you write? You multiply by negative sign, 2x minus 4. Okay, but you can simplify this. So what do you mean by 2x minus 4 is positive? Let's see that. So 2x minus 4 positive means you want to solve for x. What do you get? You add 4 on both sides, and then that will cancel. You'll get 2x is greater than 4, right? And divide by 2. So if you divide by 2, you'll get x greater than 2, right? So 2x minus 4 is same as x greater than 2. So when x is greater than 2, then gx or 2x minus 4 is 2x minus 4. The absolute value, the value of the absolute value function is 2x minus 4. But this one, if you solve this one, you will get the same technique. If you solve it like that, then you will get plus 4, and then so you will be 2x is less than 4, and divide by 2, you will get x is less than 2. So when x is less than 2, this is basically x is less than 2. So when x is less than 2, the value of the absolute value function is negative 2x minus 4. Okay, now we want to find out g negative 1, g1, g2, and g3. Let's see how to do this one. Okay, g negative 1. So when x is negative 1, where does it belong? Is this when x is less than 2, or is this when x is greater than 2? Okay, negative 1 is basically less than 2. So the value of the function is negative. So g at negative 1 will be, there is negative, and then 2 times negative 1 minus 4. Did you see that? So how much is that? So 2 times negative 1 is negative 2, minus 4 is negative 6, but there is another negative sign. So this will be just positive 6. Let's find out the other one. G at 1. Where does that 1 belong? Is that 1 is greater than 2 or less than 2? 1 is less than 2. So again, you pick this function, right? So let's do that. So g at 1. So you replace that x by 1. So negative, and then 2 times 1 minus 4. So 2 times 1 is 2, minus 4 is negative 2, and then again negative sign, that will be positive 2. Let's find out g at 2. So whenever g at 2, I forgot the equal to sign here, that should be greater or equals to. So you will get that, and then greater or equals to 2. Okay. When x is equals to 2, you pick this function, because for x greater or equals to 2, you pick 2x minus 4. Now you replace that by you replace that x by 2. So 2 times 2 minus 4. So 2 times 2 is 4 minus 4 is 0. Okay, and the last one is g3. Where does the 3 belong? The 3 falls here, right? Because x is greater than 2. Any number that is bigger than 2, the function, the absolute value function takes 2x minus 4. So you just replace that x by 3 here. 2 times 3 minus 4. That will be 6 minus 4, right? So that will be 2. In this way, you can find out the absolute value of any absolute value function. Okay. Now, how does the graph of gx look like? So how do we draw the graph of that? You make the table for 2x minus 4 and negative 2x minus 4. Let's make the table. So when y equals to 2x minus 4, make the table. And when y equals to negative 2x minus 4, make the table for that. If you pick any two values for x, that should be fine. Okay, x and then y. Let's do that. X and then y. X, y. So when x is greater or equals to 2, the function is 2x minus 4, right? So let's pick x value that are greater than 2 or equals to 2. 2 and 3. When you take x equals to 2, what do you get? 2 times 2, 4 minus 4, that is 0. When x equals to 3, you will get 2 times 3 minus 4, that is 2. So you get two values. One is 2, 0 and 3, 2. So what is 2, 0? 2, 0 is here and 3, 2 is here. Now draw a line. This is the part of the function. This is because this has two pieces, so we draw the graph in each piece. Now let's draw the graph in the second piece. Y equals to negative 2x minus 4. Okay, on this piece. So when x is less than 2, the function is negative 2x minus 4. Let's pick the value that are less than 2. Let's pick x equals to 1 and then x equals to 0. How does it look like? When x equals to 1, you plug it in here or here. When x is 1, then it will be 2 times 1 is 2 minus 4 is basically negative 2, and negative sign will be positive 2. At 1, it will be positive 2. At 0, how does it look like? When x is less than 2, means when x is 0, you will pick this function again. 2 times 0 is 0, minus 4 is negative 4, and there is negative sign. It will be 4, right? Now let me take those points. At 1 it is 2. Oops, let me take this color. And at 0 it is 4. And then look like it is a little bit here. See, you can see that the graph is still V-shaped. The graph of the absolute value function is always V-shaped, but the bottom part of the graph or the bottom part may be changed. How do we determine that? So you solve it, you'll get x equals to 2. That is the point where the bottom part of the absolute value function touches. Okay, otherwise it is always the V-shaped. All right.